Welcome to this YSL DAX for Power BI tutorial. In this part of the series, we're going to talk about rolling average calculations. We'll begin with a basic rolling average using the DATESINPERIOD function to extend the range over which an average function operates. We'll then move on and do something a bit more complicated and look at how we average other aggregations. So for example, we'll show how to average a yearly total. We'll show you how you can modify the granularity of the calculation to work with quarters and months, explain how to deal with blanks for any yearly, quarterly or monthly total, and then at the end of the video, for a bit of fun, show how you can let your end user control the range of dates over which the calculation is averaged. So let's get started. To get started, I've created a basic data model based on our standard movies data source. If you'd like to grab a copy of this data so that you can follow along with the video, I'll drop a link in the description below so that you can download this PBIX file and begin with the same data model I've got set up here. A couple of basic things I've already done. I've created a simple release calendar table, which uses a few techniques we've covered in previous videos in this series, so hopefully that looks fairly familiar to you. I've connected that release calendar in my data model to the release date field of my film table. So this is overriding the built-in automatic calendar tables that Power BI usually creates. I've also created a couple of basic measures. So just in the all measures table here, we can see we've got an average box office and a sum of box office doing nothing more than those basic aggregations. For the first visualization in this report, let's add a line chart. I'd like to show the average box office per year over the range of the data in my model. So in this line chart, I'm going to insert the year field from my release calendar release hierarchy. And then having done that, I'm going to insert my average box office measure, which will populate the y-axis. There are some big gaps in my data sort of in the earlier years, so I'm going to add a quick filter just to chop off this at around about 1960. So in the filters panel, let's add a filter based on the year field, which will show only values that are greater than or equal to 1960. And then when we apply the filter, that's a reasonably good starting point for showing rolling averages. So as you can see from this chart, there are some quite big fluctuations in the average box office between the different years in the model. The idea of creating a rolling average is to smooth out these big changes and make it slightly easier to see general trends in the data. So what we're going to do for our first example is change the way each of these data points is calculated. Currently, each data point considers the average box office for all films released in a single year. We're going to change that so that each data point considers 3 years worth of data. So for example, for the last data point, 2016, that's going to take the average of all films released in 2016, 15 and 14. Then for the 2015 data point, it'll be 2015, 2014, 2013, and so on. In DAX terms, all we're doing here is modifying the filter context. So as usual, we're going to use the calculate function to do that. Let's add a new measure to the all measures table. I'm going to call this measure AVG box office over past 3 years, something descriptive like that. And we're going to make that equal to the result of a calculate function, trying to still calculate the average box office. So I'm going to refer to my existing measure, AVG box office. Now I need to modify the date range over which that average is calculated. And the ideal function for doing that in this example is called DATESINPERIOD. So another one of the time intelligence functions, so it relies on having a well-formed calendar table, as we talked about in previous videos. The first thing we need to do is specify the column that contains the continuous range of dates. And for us, that's the date field in our release calendar table. So let's refer to release calendar date, followed by a comma, and then we have to specify the start date for the range that we're going to calculate. Start date is perhaps a little bit of a misleading name for that parameter. We're actually going to specify the last date that we want to take the range of to begin with. So I want my date range for 2016 to go all the way to the end of that year. So with the data point in my chart at the moment, I want to simply return the maximum date for that data point. So I'm going to say max, and then again refer to my release calendar date field. Then I can specify how many intervals I want to incorporate. So I can go forwards or backwards with positive or negative numbers. I want to go back 3 years from the end of 2016. And then the interval allows me to specify the units of time that I move. So as I say, I want to go back 3 years. So I'll pick year for the interval. I can then close the round brackets for the dates in period function, close the round brackets for calculate, and then create that measure. There's my 3-year rolling average. So just going back to my chart, I can add that new measure into the y-axis category and find this new line is slightly smoother than the original average box office. So it's taking the average of that year and the preceding 2 years as well. Just in case you wanted to perform a check that your calculation is working correctly, we can break it down into the basic arithmetic. So the data point for 2016 is essentially the sum of all the box office values over 2016, 15 and 14 divided by the number of box office values over that same period. Let's create a couple of extra measures to allow us to work that out and show the basic breakdown of the arithmetic. I'm going to start by copying my average box office over past 3 years measure, and then I'm going to right-click and create a new measure in the All Measures table, paste in all that code, and then change the name of the measure to say Sum Box Office over past 3 years. I'm going to change the reference to the average box office measure to the Sum of Box Office measure, and then create that new measure. Then I'm going to create a right-click, new measure, paste in the same code again. I'm going to change this name to say Count Box Office over past 3 years. I don't already have an existing measure to reference here, so let's insert the count function instead. I'm going to count the values of the box office dollars field. And I can enter that measure. And then finally, I can just divide one by the other to get the final result. So let's add another new measure. I'll right-click All Measures and choose New Measure. I'm going to paste in the same code, but this is just so that I can avoid having to type out that measure name again. I'm actually going to delete all of the code after the equal sign, and then I'll just change the measure name to say Average Box Office over past 3 years, check. All we're then going to do is use the divide function to divide the sum of box office over the past 3 years by the count of box office over the past 3 years. Once I've entered that, I think it's probably easiest to compare the values using a table visual rather than trying to read them off lines on a chart. So let's make a copy of our chart, drop it down to the bottom half of the page, and convert it into a table visual. Then I'm going to insert the box office over the past 3 years, the count of box office over the past 3 years, and finally my check column. So we can compare the average box office over the past 3 years with the check column. We should find the exact same results in every single row. One other thing you might like to do, just for your own peace of mind, is to check that the date range is being calculated correctly. And one relatively simple way to do that is to show the start date and the end date of the date range we've calculated. So once again, I'm going to head back to my original average box office over past 3 years measure, and I'm going to copy everything to the clipboard, and then let's create another new measure in the same table, paste in all that code, and then I'm going to change the name of this measure. I'm going to call it First Date in Period. This time, rather than calculating the average box office for that date range, I want to calculate the minimum date in that range. So we can use the min function to do that. Let's say min, and then we'll go for the release calendar date field again. And we can hit. I create a second measure. Working out the maximum date in the range is actually much easier. We don't need to bother calculating the dates in period. The last date in the range is just going to be the max release calendar date. So we can actually get rid of everything else around that and then just stick with the max release date. Let's change the name of that measure to say last date in period. Probably would have made more sense to copy the measure name and then just type in the function. There we go, last date in period. And once we've entered that, let's drop those two dates into the same table visual, just so we can see that for Probably makes sense to sort my table in descending order of year as well. So we can hopefully see there for the year 2016, the first date is the 1st of January 2014, and the last date is the 31st of December 2016, if I can just zoom in to make it a bit easier to read. So that all looks fairly sensible. There's our first basic rolling average calculation. So that was a relatively simple example to start with. We were already calculating an average value, and we simply expanded the range of dates over which that average was calculated. But what if we wanted to take the rolling average of some other measure, say a sum, for example? That requires a little bit more thought, so let's have a look at how that's going to work. I'm going to start by duplicating page 1, and then in my chart I'm going to remove the original average box office and replace it with the sum of box office. So it's going to show me the total box office per year. Leaving the average box office over past 3 years measure in place, you can see that the values calculated are so wildly different that it's a meaningless comparison. If you think about what this average box office over past 3 years measure is doing, it's taking the average box office of a single film over a 3-year period. Whereas, of course, there are many hundreds of films released per year, so this summer box office is a much bigger figure. What I want to do is create a measure that shows me the average of the yearly box office over a 3-year period. So I want to basically take the average of these 3 numbers shown on the last 3 values of the chart. This is often referred to as the granularity of your calculation. I suppose at the moment the granularity of this measure is per film. I want to change the granularity to per year. I guess a simple way to do this is just to take the sum of those 3 values and divide it by the 3 years. So in fact, let's make a copy of our average box office over past 3 years check measure. This is the basic pattern we're going to perform. I'm going to copy that measure, and then I'm going to create a new measure from it. I'm going to paste that in. I'll change the measure name so it says AVG yearly box office over past 3 years. Take away the word check. Now we know that this measure already gives us the total box office over the past 3 years. So all we need to do is divide that by 3. Once we've done that, if we update the measure, and then we can change our chart to take away the average box office, and then replace it with the average yearly box office, now we've got figures that we can compare. Again, maybe worthwhile showing that in the table as well. Let's take away most of the columns from that table actually, and we'll show the average box office per year still. Then let's also show the sum of box office per year, and then the average yearly box office. So again, the number for 2016, the average yearly box office, is essentially just the average of these 3 numbers here. We can take that same approach to match the granularity of a measure with the granularity of whichever visual we're displaying the values in. So let's say, for example, rather than showing the average yearly box office, we wanted the average quarterly or average monthly instead. Just before I do this, let's take the opportunity to rename a couple of these pages. I'm going to call this one a basic rolling average, or AVG for short, and then let's change the duplicate of page 1 to yearly average total box office. Hopefully that is descriptive enough. Now I'm going to duplicate my yearly average total box office page, and then I'm going to change the name of this one to say quarterly average total box office. If I can, there we go, quarterly average box office. Okay, now let's change the chart so that first of all it's not displaying the years in the x-axis. I'm going to get rid of the year field from there, and then I'm going to replace that with the year quarter field. So at this point I might need to scroll along to see anything meaningful. Maybe we should have filtered from about 1980 instead of 1960, but hopefully you can see there we're showing in the blue line, this is the original sum of box office, so the light blue line, this is the original sum of box office. This is being divided up quarterly now. Our dark blue line, showing our measure, the average yearly box office, is comparing yearly figures with quarterly figures, which doesn't really make sense. So I wanted a new copy of this measure that works out the average quarterly box office for data over the past 3 years. So let's make a copy of our average yearly box office over the past 3 years measure, mainly so I don't have to rewrite the same title. Then create a new measure, paste all that code in, and change the name of it so it's called AVG Quarterly Box Office over past 3 years. So again, the idea is still to take the total box office takings over all of the films released in that 3-year period, and then simply divide it by the number of periods. Granularity. So the number of quarters in that period will be 3 years times 4 quarters, 12. I can do mental arithmetic, excellent. So we can tick the box there. Then in my chart, let's take away the average yearly box office and replace it with the average quarterly box office over the past 3 years. Then again, if we just scroll along so we can see something a bit more meaningful, there's our nice smoothed out line showing or comparing quarterly figures with quarterly figures. We could also update the table to show that as well. So let's in fact delete that table altogether. Then we can just make a copy of our chart, and then we can convert the chart into a table. I'll sort it in descending order of year and quarter. We're showing the sum of box office for that quarter, and then the average quarterly box office over the past 3 years. So this is taking, as I say, the sum of all the box office takings from the end of 2016 to the start of 2014, taking all those numbers and dividing it by 12. At this point, we may also want to consider changing the range of dates we're using to calculate the total box office. If we're comparing figures quarterly, then it is perhaps a little excessive to use data over the past 3 years. Let's say we wanted to consider just the past 3 quarters instead. To help with this, let's start by making a copy of our sum box office over past 3 years measure. I'll paste that into a new measure, and then we'll change its name to be sum of box office over past 3 quarters. Then we can modify the interval argument from year to quarter and create that new measure. Then we're going to go to the average quarterly box office over the past 3 years measure, and we'll make a copy of this, paste it into a new measure, change its name to be average quarterly box office over the past 3 quarters, and we'll take away a reference to our sum of box office over the past 3 years and replace it with sum of box office over the past 3 quarters. Finally, we can just adjust which value we're dividing that by. So how many quarters in a 3-quarter period? Well, even I can do that mental arithmetic. We'll divide it by 3. So we're changing 2 things here. The sum of box office over the past 3 quarters controls the range of values being used to calculate the total, and then the divisor, the number we're dividing by, is simply controlling the granularity. So if I enter that, and then we can maybe add that new measure into our same chart. Let's go for average quarterly box office over past 3 quarters. So I put it into the table there. I guess I want to do that anyway. Let's also add it into the chart. And there we go. So a slightly less smooth line because we're incorporating less data, but the figures are still comparable because the granularity is still quarterly. So again, we can take that exact same approach if we wanted to change the granularity to a monthly level. Let's make a duplicate of the quarterly average total box office page, and then let's change its name to say monthly average total box office. And then let's change the granularity of our chart. We'll take away the year quarter field from the x-axis, and we'll replace that with the year month field instead. So again, we've got this sort of disparity between the granularity of the sum of box office in the light blue line and the rolling averages, which are using a quarterly granularity at the moment. So let's get rid of those extra lines there. We'll get rid of the average quarterly box office measures, and then we'll replace those with a monthly version of the same thing. Let's start by heading up to our list of measures. Let's just change the width of this so we can read the names more clearly. So I'm going to go for my average yearly box office over the past 3 years. I'm going to take a copy of that measure and then paste it into a new one. I'm going to change the name of the measure to be the average monthly box office over the past 3 years. So we're going to take the sum of all the box office takings over the past 3 years. We simply want to divide that by the number of months in 3 years. And again, a bit of mental arithmetic, 36 in this case. So once I enter that, I can add that measure into my chart. We will see, oops, try that again. We can see, if I scroll along to the right, that the figures are now a bit more comparable. Again, it's a little excessive, perhaps, to consider 3 years' worth of data when we're comparing monthly averages. We could use the quarterly figure instead. Let's take the average monthly box office over the past 3 years, the one we've just created, copy that, and then paste that into another new measure. I'll call this one average monthly box office over past 3 quarters. We already have a measure which takes the total box office over the past 3 quarters, so I can refer to that one here. Then we simply need to divide that by the number of quarters, or so beg pardon, by the number of months in those quarters. So there are 3 months per quarter, 3 times 3. Once again, bit of mental arithmetic, we can change that to 9. So if I hit enter, and then again, I'm going to insert that new measure, average monthly box office over the past 3 quarters, into my chart, and then slightly less smooth line. Again, if we wanted to take an even shorter date range, we could just take the sum of box office over, say, the past 3 months. And let's have a quick go at doing that. So I'm going to make a copy of my sum of box office over the past 3 quarters measure. This gives us the total box office value. Create a new measure and paste that in. Change its name to say sum of box office over the past 3 months. And again, modify the interval property to use month this time. So once I've created that, we can finally go back and create one more copy of either of these 2 measures. It doesn't really matter. I'm going to go with the average monthly box office over past 3 quarters. And I'll paste that into a new measure. And then we'll call this one average monthly box office over past 3 months. Take the sum, replace that with the sum of average box office, sum of box office over the past 3 months, and then divide it by the number of months in 3 months, which of course is just 3. So finally, adding that measure into that table, we've got multiple different rolling average granularities. I suppose the most appropriate one in this case would be the final one, the purple line for the rolling average over 3 months. And again, just to compare that in the form of a table, let's get rid of that table visual, copy and paste our chart, and then convert the chart into a table. So there we go. So for the past few examples, we've been taking a fairly basic approach to working out our rolling average. It's kind of similar in principle to the way we broke down the basic arithmetic of our original example from the start of the video. If you remember, we separately calculated the total box office for the required period, in this case 3 years, and then divided that by a number representing the granularity of the calculation we were aiming for. So in this case, it was the number of box office values over the same period. Subsequently, we've been manually typing in the required number of years or quarters or months to modify the granularity. And there's nothing specifically wrong with this approach. It works, of course. And it's kind of nice in a way because you can easily see and follow the logic and the sequence of the calculation to see what's going on. But it's not the most elegant way to do this. The main issue I have with it is having to type in these magic numbers, these constant values representing the number of years, quarters and months. I think we can do better. Now, the approach we're about to take is more elegant, I think, but its downside is that it's a lot less transparent. It's less easy to see what's going on. You kind of have to use your imagination at least a little bit. But I still think it's worthwhile seeing how this works. So to demonstrate this, we're going to make a new version of our average yearly box office over the past 3 years measure. And just to try to help explain what's going on, I'm going to zoom in on the table on that second page there. I'm going to get rid of the average box office value. That's kind of irrelevant at this point. And think about what's going on with our sum of box office over the past 3 years measure. If we just have a look at the code here, this is essentially calculating one single number representing the grand total over this period. And you can see this in the last column of the table. In the next measure, what we've done is take the result of that column and then just divide it by 3. That's the bit I have an issue with. The thing I think we can do better is I think we can use this same measure that gives us the sum of box office over the past 3 years, rather than to calculate one single number for each data point, we can change this part of our formula to calculate a little miniature table. Essentially, what we would be doing is inside that measure, inside that calculate function, for the 2016 data point, we could calculate that table of results. So it would contain 3 years, 2016, 15 and 14, and give us the sum of box office individually for each of those 3 years. Then all we would need to do is take the average of those numbers to end up with the exact same figure we've got with our original approach. So that's the trick. Here's how we do it. What we're going to do is nest inside our calculate function, not just a reference to the sum of box office. We're going to use the average x function to take the average of an expression. The first thing average x needs is a table over which to perform its expression. The table we're going to generate, I want to contain a list of the 3 individual years, 2016, 15 and 14. One way to do that is to use the values function. And the values function can return a single column table if we reference the column we want to return the values from. The column I want to return the values from is the year field from our release date calendar. So I'm going to use the release calendar year field to pick up and return that column of 3 results, 2016, 2015, 2014. Then, for each of those rows in that table, I want to work out the sum of box office. And then if I close the round brackets for the average x, that's basically the entire thing. Now obviously I don't want to modify this original calculation because that'll break everything else. So having just done all that, I'm going to copy everything I've done. Then I'm going to press escape to abandon the changes I've made to this calculation. We can hit the cancel button there to do the same thing. Then let's create a new measure, paste in all that code. I'm going to change it to be called AVG yearly box office over past 3 years V2. Okay, so entering that new measure, I'm going to drop this into my table visual, just placed immediately after the original average yearly box office. So hopefully you can see that we get the exact same results for every single year. Now, the big advantage of this approach, I think, is how easy it is to modify the granularity of the calculation. All we need to do is alter the column we're referencing in the values function to change the little miniature table that's been generated internally inside the measure. So let's have a go at copying this measure to repeat the same thing for the quarterly granularity. If I copy that and then create a new measure, paste all the code in, and change the name of this one so that it's called AVG quarterly box office over the past 3 years V2. so we'll keep the date range the same for the moment. This time inside the values function, rather than referencing the year column, we're going to reference the year and quarter column, or year quarter. So if I enter that, let's switch to the quarterly average total box office page. And then, once again, we've already got the average quarterly box office over the past 3 years measure inside our table. If I drop in our second version side by side with it, you'll see that once again, it's exactly the same result. If we did want to change the date range over which the calculation is being performed, then again, that's really nice and simple. We can just alter the interval property of the DATESINPERIOD function. So if I grab a copy of that entire measure, average quarterly box office over the past 3 years V2, paste that into a new measure, and then change its name so it's average quarterly box office over the past 3 quarters V2, then we can just update the year interval to the quarter interval instead. Again, my table visual, which is probably the easiest way to make the comparison, already shows me the average quarterly box office over the past 3 quarters. So adding in the second version of that measure should return the same end results. Can't quite scroll far enough to the right to make that visible. Let's zoom out. There we go. So same results, just in a slightly more elegant way. So far, both approaches have apparently returned the same results, but that may not always be the case. Let's demonstrate that by creating a version of the average monthly box office over the past 3 years using the new approach. I'm going to make a copy of the average yearly box office version 2, then paste that into a new measure and change its name to be average monthly box office over the past 3 years V2. Again, to change the granularity of the calculation, we just modify the column referred to by the values function. So this time we'll refer to the year-month field, and that'll produce 1 row in the little miniature hidden table for each year and month. So when we update that, we can add that into our table visual on the monthly average page. Let's make sure we pop it in the right place to make it easy to compare. So side by side with the original average monthly box office. So if we just have a quick look at what's going on, again, on the surface at least, if we look at the first few rows, everything matches beautifully, clearly working out the correct or same result. When we get down to January 2016, however, things go a bit wonky. There's a different result in these 2 columns. So what's going on there? Well, January 2016 was the trigger. If we go back 3 years from the end of Jan 2016, we get to the beginning of February 2013. So let's scroll backwards and see what's going on. There we go. February 2013 has no value. It's blank. So our original version of this measure, average monthly box office over the past 3 years, is simply dividing by 36. It's assuming that every single month in that 3-year period has a value. Whereas the average x function, like all aggregation functions in DAX, ignores blanks. So basically, this is essentially taking the sum of box office for that period and dividing it by 35, if you want to think of it in basic arithmetic terms. I guess we have to make a decision about which version is correct. If we consider the second version to be correct, essentially ignoring the blanks, then we can fairly easily modify our original formula here to divide by 35. But while that will make it work for January 2016 now, if we go back up, so Jan 2016 figures now match. Annoyingly, everything else now doesn't match, because of course there'll be different numbers of populated months in each period. So rather than working out or manually typing in that number, we could work out how many months are populated. Oh, how do we do that? Well, let's head back to our version 2. I think what I'm going to do is grab a copy of that calculate function that works out the average of box office. I'm going to copy all that, head back to version 1, and and replace that hard-coded constant number 35 with my calculate function. I don't want to take the average box office for those different year-month rows. I just simply want to find out how many there are. So if we use a COUNTX function, we'll find out how many sum of box office values there are for each row, or for the combination of rows generated by that values function. So if I enter that formula now, and then have a look at the results, if I can just switch away from that measure, there we go. So Jan 2016, the columns now match again, but as do all of the other columns. So we're correctly calculating how many populated months there are in that date range. Personally, I think that might be the wrong approach. If these were sales figures, for example, and February 2013 had no sales, then really the value for that month would be 0. So I think we should incorporate February 2013 and any blank months in our calculation. I think we want to do the opposite of what I've just done here. So how do we do that? Well, first of all, let's change this measure back so it's dividing by 36. So that's the original approach. So we'll consider every month to be a valid value. Then, if we go back to the version 2 measure, what we basically want to do to make our average x function incorporate the sum of box office when it's blank is to convert a blank value into a 0. And there's a couple of ways we could do that. We could write an if is blank combination of functions, but a slightly more elegant approach is to use the COALESCE function. So the idea behind COALESCE, if you know SQL Server or SQL, you may well know about COALESCE already. The idea is you list out a range of values, and whichever the first value that is not blank, that's the result you get. So ideally, I'd like to return the sum of box office first. But if that is blank, I can type in a comma followed by a 0, and I'll get a 0 when the sum of box office is blank. So all that slightly rambling explanation aside, if I update my formula to take that into account, now we can hopefully see that if I go back up to January 2016, January 2016 matches the original figure calculated by the first approach. We should probably use this same approach of using the coalesce function to return a 0 when the sum of box office is blank for all of the other granularities we've looked at here so far as well. While it's kind of unlikely there will be entirely blank years, it's certainly possible there could be some blank quarters. In fact, if we head back to the quarterly page and just zoom out and scroll down the table, it's quite possible that towards the end, indeed, we've got some entirely blank quarters. So again, we'll have a mismatch between the two different versions of the formula. If we go back to our average quarterly box office version 2, change just the basic sum box office to the coalesce version of that, then we'll get back to the point where both approaches give the same result. And just for absolute certainty, let's change the version of yearly box office version 2 as well. If we head back, change that to coalesce, and then I think there's one more as well. There's the average quarterly E2 as well. So the average quarterly box office for the past 3 quarters, we should also use the coalesce function to make sure that we return zeros when that is blank. So at this point, we've got a fairly robust measure which lets us calculate a rolling average for any granularity over any period of time. And it's fairly easy to modify either of those two aspects of the formula. To modify the range of dates over which the average is calculated, we can change the number and the interval parameters of the DATESINPERIOD function. And to modify the granularity, we can change which column we reference in the values function. The only thing I think missing from this example at the moment is any sort of user influence over the result. To modify the results of the calculation, we've got to actually modify the calculation itself. So just for a bit of fun at the end of the video, we're going to make a new version of the average yearly box office formula that lets the user pick the number of years over which the average is calculated. So to start with that, I'm going to duplicate my yearly average total box office page, and then let's change its name so it's something like yearly average total box office user choice. And I'll spell choice properly as well, otherwise I shan't sleep tonight. There we go, choice. Then let's make a copy of the version 2 of the average yearly box office measure, and we can paste that into a new measure. I'll change the V2, or take away the V2 entirely, and change the number 3 to the letter N, indicating it's going to be a variable. But I am just going to keep it set to the number -3 at the moment. Okay, next let's make some changes to the page. If I delete that table at the bottom altogether, and then in the chart I'm going to take away my original average yearly box office and replace it with a new measure I've just created. It'll look the same at the moment, but don't worry, that'll change shortly. Now there are several ways to allow the end user to influence the value passed into a measure. You'll see some more in the next section of this tutorial series. We're going to start with a fairly simple approach. We're going to go to the Modeling tab in the ribbon and use the New Parameter option. We'll talk about this in more detail, as I say, in later videos in the series. For now, we're going to pick a basic numeric range parameter. It's going to be a numeric range. I'll give it a sensible name. I'll call this one number of years, nice and descriptive. It's going to be a whole number. I want to set the minimum. I always want to pick at least 1 year. But the maximum, I'm going to limit that to 10. And the value is going to increment by 1 for each step. Just to help out as well, I'm going to get the dialog box to add a slicer to the page. So when I click the Create button, we'll end up with a nice simple slider slicer. And I can see that if I click and drag on this slider bar, it changes the number selected in this box there. What's also happened, if I just collapse my All Measures table for the moment, you can hopefully see that I've got a new number of years table in my data panel. And inside there are two things. First of all, the number of years column. That's been generated with a really simple generate series function, starting at 1, ending at 10, and incrementing by 1 for each step. So that's generated a calculated table, basically. And then there's a measure nested inside that same table that simply picks up on the selected value of this column. So this is influenced by the slicer, of course. If I choose a different option in the slicer, that number is returned by the number of years value measure. I could have done all that manually, but it's far more convenient, of course, to use the new parameter option. So all we need to do now is modify the measure that I want to let the user control. So go back to the average yearly box office over past n years, remove the number 3 from the DATESINPERIOD function there, and then from your list of measures, we can pick the number of years value measure. Okay, so when I update that measure now, I'll just clear that. We can hopefully see at the moment that the average yearly box office over past n years is essentially the same as the sum of box office per year, because I've set the average to 1, or the date range to 1 year. If I start increasing this, we'll start to see that measure changing, gradually getting smoother and smoother the longer the date range I pick. So a little bit of fun, not perhaps the most practically useful thing you'll ever encounter in Power BI, but still a bit of a nice way to end the video. So hope you found that one useful. I know there's quite a lot to unpack in that one, maybe worth watching more than once. Let us know what you think in the comments. Thanks very much for watching as always, and we'll see you next time.